So those websites and YouTube videos that I had you look up, we're going to be looking into those topics. And then next class, we're going to be looking at ray diagrams. So after today's lessons, I encourage you to scroll down the page and check out some of the websites and YouTube videos that your classmates found and deemed to be the best out there. Okay? All right. So let's get started. So what we want to be able to do after today, we want to be able to label a diagram of the eye, describe how an image is formed by the eye, compare the functions of the parts of the eye to the parts of a camera, and finally describe eye defects such as myopia, hyperopia, and astigmatism, and how they're corrected. Okay. All right, so let's look at parts of the eye. The first part is the cornea, and that's the clear window at the front of the eye that covers up the iris and the pupil, which we'll define very shortly. Okay, so when you touch your eyeball, what you're touching, the first thing you're touching is your cornea that you could actually touch with your finger. Okay. Then there's your pupil. Okay, and that's the black dot. Okay, so if you look really, really closely in your eye, the colored part of your eye, there are two circles, okay? And the smallest one is your pupil, and that's where the light enters your eye, okay? Then there's the iris. So around that black dot, you have some more um, pigmentation around that area, and that's called the iris. And that's the colored part of the eye. So usually for most of you, your eyes are brown, but it can be blue, green, depending on your ethnicity. So the colored part of the eye that surrounds the pupil, and it controls how much light, enters the eye by changing the size of the pupil. Okay, so it can actually open your pupil to let more light in. Anybody knows what that is called? So has anybody ever gotten
Acting or something like that?
Like dilating and constricting.
Somebody said it. It begins with a D.
Dilating and constricting.
Right. Awesome. Okay. So when you dilate, you actually open it up some more. I recently got my eyes tested over the Christmas, and that was the first time that I'd experienced that, at least that I could remember. I probably did it before when I was smaller, but when you get your eyes tested, the eye doctor will put some liquid drops in your eye that cause your pupil to open up very, very wide so he can be able to look at it more clearly. And usually you can't see too well that's happening and you look kind of funny. You could Google pictures of dilated eyes. You kind of look like a little bit of a zombie for a couple of minutes, but it's very cool. So the iris is the colored part that surrounds the pupil. Then we have the lens. And true to the name, it's just like the type of lens that we talked about. So it, once the light hits the lens, it like sort of like a camera lens by focusing light onto the retina at the back of the eye. So What do you know about what light does to lenses? What happens when light passes through a lens?
It refracts.
Exactly. It refracts, it bends. So we actually have small muscles at the, it's not shown in this particular diagram, but small muscles at the edge of those lens called ciliary muscles, and they can pull or push the lens to change its shape, like you saw in the simulation. If you did that part where you made the lens, kind of fat or kind of skinny, and you saw that that affected the image properties. Well, our eyes kind of do the same thing, depending on um, the image that we need to focus on, or the object we need to focus on, how far it is, how much light we have. The shape of that lens in our eyes can change to cause the light to bend in the direction that it needs to focus on the retina. What is the retina? Well, you can think of it like a screen. That's where the image is focused on. That's where it's supposed to be focused on when you have normal vision. Okay, so for most people who have normal vision, all of the light ends up at the back of the eye, and what happens there is the light is focused and then it travels as electrical impulses to the optic nerve. So that's connected to our brain. The optic nerve's connected to our brain, and that's where we're able to interpret what we see. Okay? So all of those parts, you need to be able to recognize them and state the function of them. All right. So let me just take it back. I want you to look at it. I'll give you 30 seconds, and then I'm going to have you answer a question. Study the diagram. Let's see how good your short-term memory is. Think about what comes first. So the corneas in the front, the colored parts, those are the pupil and the iris. The pupil is in the center of the iris. Behind the pupil, we have the lens, and the two at the back, we have the retina, which is the inside lining at the back, and then we have the optic nerve. So that's the stem leading out to go to the brain. Okay, think you got it? All right. Tell me which letter indicates the retina of the eye in this picture. Excellent. Good job. Just for fun, what is D?
Nerve.
Awesome. Okay. So this is a picture pulled from a paper one. So as you can see, the diagrams are very, very simplified. Okay. So they're not gonna have all those, nice colors and be so animated. So you need to be able to go from this to that. Okay. What C?
Lens.
Good job. And what is A?
Yeah. Pupil.
You haven't given me a chance to ask the question yet. Awesome. All right. What about this one? Which letter indicates the cornea?
A.
Awesome. What is B?
No.
Mm-hmm. And what about C?
Lens.
Yep. And D?
Optic nerve.
Awesome. So as you can see, they were really lazy in drawing this diagram, but the structure, you have to have that in your mind no matter, oh Lord, no matter how simple the diagram is, okay? The structure is still the same. It helps to remember them in order of what comes first, as if you're going back layer for layer, okay? Good job. So what is the path of light through the eye? So the first place it has to pass through, of course, is the cornea, okay? Then through the pupil, the iris, the lens, ciliary muscles, okay? I'm gonna put a, I'm gonna put a circle around because I wanna be accurate, okay? I'm gonna put a circle around those things that the light doesn't actually go through, but it
I mean the
helps.
iris.
Right, so I have the iris here, but the iris and pupil, they kind of go together. The light doesn't like go through the pupil and then come out and go through the iris. You know, it has to go in a straight line. So that's not what I'm saying. The iris helps the pupil let the light in by opening it wider or closing it if we, if we need to protect our eyes from too much light. So let's put a star next to iris, and that goes with the pupil. So it actually is going to pass through the cornea. It's going to enter the pupil. And then the ciliary muscles, again, they go with the lens. So they help pull or push, stretch or compress the lens to help the light focus on the retina, okay? So it doesn't actually go through the ciliary muscles, okay? But it does pass through the lens. It does focus on the retina, and electrical impulses, it's turned into electrical impulses that go through the optic nerve, okay? So let me just be careful about including the iris and the ciliary muscles in there. So just know that those are like just helpers along the way. Okay? All right. Clear that. All right. One of the things that is interesting to do, and you're going to have an assignment that's going to take you deeper into this, but there are many, don't be so excited, Chardonnay. There are many similarities between the camera and the eye. Okay, so I'm not gonna go into this very much, but I just included this diagram so you can get an idea of those parts of the eye that are like the camera. So one that's really, really obvious, of course, is, when well, we have camera phones now, so we don't see all this, but like a real camera that's just for taking pictures, okay? It has a small lens at the front where the light enters, called the aperture, and that's kind of like the pupil of our eye. Okay, so it has an opening, and then it also has a lens to focus the light, just like our eye has a lens to focus the light. Now these are old time cameras we're talking about that have film. Okay, the film is like the retina. That's where the light is at the back. Okay, so I'm gonna have you do some research on this so you can see how this works. Okay. All right, let's talk about vision. So, two things we need to define when we're talking about vision are far point and the near point. So the far point is the maximum distance to which the eye can see objects clearly. Okay? And the near point is the minimum distance of an object from the eye can be seen without strain. Okay? So your near point is the closest distance you can see without straining your eyes, and the far point is the farthest distance that you can see an image clearly. Okay? Now, people with normal vision, like 20/20 vision, you don't have any defects of the eye, can focus clearly on distant objects at infinity. Okay? So we say their far point is at infinity. Infinity, of course, means on and on and on and on as far as the eye can see. Okay? But when we talk about your near point now, people with normal vision can also focus as close as 25 centimeters from the eye. Okay? So just to give you some context, the length of your finger is about a centimeter. So if you hold an object about 3 finger lengths from your face and you have 20/20 vision, you should be able to see it clearly. Okay? Let's see how good you guys' vision is. If you have your phone or whatever in front of you, well, everybody's looking at a screen, so we'll do this for a short while because I don't want you to tap with your eyes. But take 3 fingers and line them up at the screen, and I want you to put your face close to the screen and tell me if you can focus on the screen at that distance. You mean if I can see the words clearly? Can you see the words clearly?
Yes, ma'am.
I have good eyes. Are you wearing glasses?
No, I am not.
Yes, you need carrots. I wouldn't even try. No, I can't see that. All right, so normal people just get really close to the screen. That's all I'm saying. All right. So normal people can see about 25, can see an object that's about 25 centimeters from your eye. So the near point for adults with normal vision is about 20 centimeters. For teenagers, it's a little less, maybe about 20. Okay? Now, a lot of people don't have normal vision, especially as you get a little older. So then you probably need glasses. You're gonna see if you can't see close, you're gonna tell me in a minute which eye defect you might have. But don't take my word, you go get your eyes tested when this is all over. All right. So eye defects. So the first one is hyperopia, and this is sometimes called long-sightedness or far-sightedness. Okay. So people with hyperopia can focus clearly on very distant objects, but cannot focus near objects. So this is because the eyeball is too short, or the lens is too thin in their eye. And this means that a ray of light from a close object becomes focused behind the retina. So it goes too far back. So you miss the image. So in order to fix this, no, just maybe across a field. It depends. Relatively far. Okay? Not like seeing, when we're talking about seeing through walls and stuff, just what should be normal is not normal for this person. Okay? So this person, when they get their glasses, so even though you see lots of people walking around with glasses and they all look the same to us, glasses is glasses. They're not actually, depending on which eye defect you have a different type of lens. Okay, that's why you can't borrow people's glasses, because if they're not made for you, it's not going to correct the vision. The Bahamians like to wear people glasses. That's not right. You wear the glasses that are made to correct your specific eye defect. So a person who is long-sighted should wear a convex lens. Remember, convex lens converge light, so they bring it together. So it kind of like pulls it in. Okay, so I think both term. I don't think the former. Let me see. Hypermyopia. No, hyperopia. And then you put two of the words together. So it's hyper and myopia. Okay, we're going to talk about myopia next. Okay, so convex lenses, like the one in your simulation, it brings the light rays close together or converges the light rays. And that's good for a person who's farsighted, because the reason that they can't see is that the light is spreading out too far and it's passing the retina. So when they wear a convex lens, you can see near and far, but only for a short period of time. I'm familiar with an eye defect with that description that has to do with a period of time. It's either you can see it or you can't. So you're not gonna be able to see it 1 minute and then you have perfect vision the next. So you may just be talking about, eye strain. You can see normally for a while, and then after a while, your eyes become strained. So that is probably a sign that you have an eye defect, that you need glasses. Okay. But again, I'm not a doctor. I did not study um, eye defects to that extent to be able to diagnose you. So you should get your eye tested if you feel anything that's not what I described as normal vision. Okay, so there's simple things you can do. You can you can actually do the eye test with letters. You could do that at home. I've done that at home before. There are actually those you can print out online. You just need a tape measure. That might be interesting for some of you to do after this lesson. You can print out um, what do you call those? Just 20/20 vision test, and you'll see like the letters come up with the big letters on top, and you have like 8 lines, and as they go down and get smaller, which is the eye doctor, and
I think I have 29.
you can print that out and put it on the fridge and measure about 10 feet, and you can do the test yourself. Cover one eye, read it off, and see how many lines you get down, and it'll tell you um, out of 20, how good your vision is, and that can give you an idea. Okay? So try that and see what you're working with. Okay, so the person who's long-sighted should wear a convex lens so the light rays can converge at a point much closer and be focused on the retina. Okay, so the convex lens kind of pulls the light together so it can focus on the retina so they can see properly. Okay, so the top picture up here shows what the light does when the only lens that is being used to focus is the person's eye lens. But the bottom, the correction now, where we have the light passing through the convex lens before it goes through the person's eye lens, results in focus on the retina. Corrected. Okay? So that's the first one. Hyperopia or long-sightedness. So that means the light ray goes too far. It's hyper. It's going too far. It's passing the retina. That's not what we want. Okay? We use a converging lens or a convex lens to pull it back in and make it focus on the retina. Do they make glasses where one is a correction lens and one is the other? It's just a piece of glass. Our eyes come in pairs for a reason, I think. So whatever is wrong with one, because you like if one is strained, the other one is probably going to be strained as well. Think of it like tires. If you're going to fix one tire, then you might as well fix the other. So I don't I don't think you'd have a case like that unless the other eye is like damaged or something. But even so, it can hurt to to put a lens in the other one. I don't know. I don't see a reason why somebody would do that.
I think if yeah, if you said if it's the other one is damaged, because that could happen. If one side is more damaged than the
I guess if they want to save lens, then they'll say, well, this one is damaged, so you don't need it. Um, People born with one eye smaller than the other. Again, These are questions for an eye doctor, which I am not. Okay? So, good questions, interesting ones that I too would like to know the answer to, but I don't know. I don't know about people who are born with one eye smaller than the other.
Some could be born with like the retina not being able to attach or it's not developed properly. So one of it could be stuff like that.
Right. Again, that's a problem that cannot be corrected with glasses. That would have to be corrected with surgery because the glasses only focus the light so it can reach the retina. Now, if something's wrong with the retina, that's a totally different problem.
Yeah.
One second. All right. So that's the first type of eye defect, long-sightedness. So let's talk about the other, nearsightedness or myopia. Okay. So people with myopia can focus clearly on very near objects, but cannot focus distant objects. Okay. So if you ever see, like your Grammy or your grandpa, and they're reading, they take a book and they hold it up way in front of their eyes in order to read it, most likely they're nearsighted. Okay. So the reason for this is because either their eyeball is too long or the lens is thick. So what happens is before the light reaches the retina, it converges. So the image is not formed on the retina, it's formed in front of retina. Okay? Which does us no good because if the light doesn't reach the retina, then we won't get as many electrical impulses being sent to the brain and our image is going to be distorted. Okay? So, myopia, nearsightedness means the light doesn't reach the retina. So, it needs to be the light rays. We need a ray that's going to spread it out, push it back. A lens, sorry, that's going to spread it out or push it back. So, this type of person should wear a concave lens or a diverging lens. Because what we want to do is spread the light out some more so that when it does come together, we're going to like stretch it out. When it comes together, it's focusing on the retina. So myopia, nearsightedness, the light does not focus, on the retina. It becomes focused in front of the retina. In order to correct that, we use a concave lens, aka a diverging lens, that is going to spread out the light rays and push back the focal point. Okay. Can you hear me now? Just turn it in. Concave lens for nearsightedness, to spread out the light. Okay. Well, I just read what's on the screen, so everything I said is on the screen. So no worries. And I'm recording as well, so no worries. All right, so I have a question for you. I need some detectives. So, further investigation. Two suspects, A and B. Yes, you're getting paid with the pride of a job well done. In a certain murder investigation, two suspects, A and B, are accused of shooting the victim from a far distance. Suspect A suffers from myopia and suspect B suffers from hyperopia. An eyewitness says that the shooter was wearing glasses at the time of the crime, which were later found at the scene. Spectacles are examined and are found to be concave lenses. Which suspect could have been the shooter? Y'all have somebody life on the line now. You better be sure.
Whichever suspect has myopia, so I don't know what that one is. A.
Are you sure, sure? The verdict is final.
Yes, ma'am.
There should be no question marks. Let's see if your verdict is supported by the evidence. Suspect A is definitely guilty. Concave lenses are used to correct what?
Myopia.
Myopia. Okay. All right, good job. Traditional question now. So a common eye defect is shown in the diagram. Which row shows the eye defect and its corrective lens?
B. I think.
Mhm. All right, let's see if you're right. Correct. Awesome job. So as we can see, the light is focused behind the retina. This is hyperopia. Too far, too far. So the person is farsighted, and to correct that, we use a converging lens, aka a convex lens, to bring it together. Really good job, guys.
Miss Connie, what lens you use well? Concave or convex? I mean, in your glasses.
I don't know. I have astigmatism, so I don't know. I have to find out. But if I had to guess, astigmatism is when your eyeball is too like oblong. It's not a circle. It's kind of like an oval,
You need a
which means
concave.
the lens should be like kind of fat.
So that
So the
means yeah, I get where you going. I think the light will converge in front of the retina. I think you be wearing a concave lens in your glasses. I'm sure though.
I think so too. Yeah. So I think that brings me. Yeah, that's gonna bring me just about to the end. I think that was my last question. So let's talk about. This is a very interesting topic. There's lots to talk about when it comes to this. All right, so I'm gonna have you do a little bit more into this. because there's so many things to talk about that it's not practical for us to, do this the traditional way. So, a couple of things you're going to do, and you're going to have all week for this. Um, of course it is. Of course it is. Come on now. Do you not know me by now? So, don't be afraid of the videos. You don't have to actually do anything with the videos. I just want you to watch them. Okay? So, you found some videos, and I found a couple more. So the first one is on how the eye works, and all they're nice, animated, easy to watch, no more than like 3 to 5 minutes. So you can watch one every other day or so. How does the eye work? One is on hyperopia, the other is on myopia, and then the last one is what I really want you to watch. If you don't watch any at all, please at least watch the last one about the eye and the camera. Okay? To give you some perspective, but I do want you to watch them all. Okay? So, first assignment is to watch those videos. The second assignment is a worksheet, Edmodo. I think I posted that already. All right, just some question and answers. I said you have all week, this week. So, you have a couple of questions to answer. Then, I still have not uploaded this. I have to upload this rubric, but really and truly just, for assignment number 3, maybe PowerPoint, I don't think I have to go too much into this. You've made PowerPoints for me before. You know what I'm looking for in terms of how it should look, how many slides. I guess I can give you, let's say, no more than 20, okay? 10 to 20 slides should be sufficient, all right? And you're going to pick a topic, okay? You're not going to do all 3 of those. I'll do that, all right? So you're going to pick one of these topics. So the first is eye defects. So you include all mentioned, hyperopia, myopia. I mentioned astigmatism. We didn't go into that, but I want you to include that as well, okay? It's in the objectives, so I want you to include that along with glaucoma and color blindness, okay? So that would be 5 in total for eye defects. Then the other 2 have to deal with just application of lenses, okay? So the second topic would be telescopes and binoculars, and the third topic would be the microscope and the projector, okay? So choose any one of those 3 topics to do a PowerPoint on. If anybody has difficulty doing a PowerPoint, you can just as well write an essay, okay? If you prefer that, I can give you that option, okay?
I like
So PowerPoint, or you can write an essay. Okay, I can do that. All right, so are there any questions? Okay,
essay.
yeah, so PowerPoint or essay on one of these topics. All right, so you can head over to Edmodo to get this PowerPoint. It should be up there now, and you can get started on your assignment. Go ahead, Sarah, I'm listening. What's your question, Sarah? Oh, uh-huh. This last slide or the previous slide? This side? Uh-huh. Everybody else, if you're done and you don't have any more questions, you're free to log off. Sarah, you can stay and ask your question. Okay. I'll see you guys on Wednesday. Bye. Okay. All right. Farsighted is the same thing as long-sighted, okay? So if we go back a couple slides back, long-sightedness, that's when the light is focused behind the retina. So the point where all the light rays converge, it's behind the retina. It looks like it's going outside of the eyeball. Okay. And if you look at the picture in the question, that's the case here, okay? These are the light rays with the arrows, and they come together behind the retina. This would be the retina here, the edge. Retina. And this would be our focal point, but it's behind the retina. So this is farsightedness. Okay. You can think of it like when the rays are too long, long-sightedness, the light rays go too far, farsightedness. Do you see that? All right. So go ahead and download the PowerPoint from Edmodo and go over it from the top so it sinks in, okay? All right. No problem. Yes, good morning, grade 10. We're going to start in about 3 minutes or so.